When we create variables, if I just say int x, right now what happens in RAM is that a variable called x will get created, and it's going to be allocated the amount of RAM that an int takes, okay, which is 4 bytes. We call x at this point an uninitialized variable. It is a variable that's created, but it has no value in it, okay? When does it get a value? It gets a value when I say x equal. Now, I could have initialized it on the same line. I could have said int x equal to k.nextInt, for example. But here, if I just say int x, we say that this is an uninitialized variable, and it's getting initialized on the next line when I set it equal to a value. The same way, the same thing is true about variables that store references to objects. If I just say student Tweety, we say this is an uninitialized variable. And when does it get initialized? When I use the new keyword to create a student. Why does this matter? It matters because if you have an uninitialized variable, you cannot use it. So for example, if I come here to main and I say int x, and I try to print out x, Java's not going to let me. It's going to complain that x is uninitialized. So you cannot use a variable until you have initialized it. The same way with a student. If I come here and I say student Tweety, and then I say, okay, and here I created a new file called student2. So we're going to have to use student2 in this file. Student, and I try to print out, for example, Tweety. I'm going to get that it's uninitialized. And if I try to call methods on it, like get name, oops, I had a typo in there. Let's try again. Here it'll tell me that it's uninitialized. It won't let me do that. And of course, if I try calling a method on it, it's not going to let me because it's uninitialized. So just like variables that we've been creating before, we could not use before initializing them. The same way here, I cannot use an object without having it being initialized. I have to make sure I create it first before I can start using it. Okay. So just a reminder that this applies to objects the same way it used to apply to primitive data types that we've been creating before. Now, here, when we create an object, okay, if I create a student and this student is storing name and test1, test2, test3, those variables that are in student are uninitialized. When do they get initialized? They get initialized in the constructors. So let's go back to our code here, and I just created an empty student. Let's look at our empty constructor that we wrote before. It does nothing. It is not saving anything in name, tuition, major, or GPA. Now, what if I want to print what's in them? Well, I can use the methods. You can also use the dot notation and access the actual information. So here I can say, for example, Tweety dot major, because I don't have a get method. Now I can do this because I am the owner of the student class, so I can do this. Remember, student major was private, and you will see that there's a lock next to it. When there's a lock next to something, that means it's private. So major is private, name is private, GPA and tuition are private. Our methods are not private, and that's why we don't see this lock here. But because I am the owner of major, I can access I'm the owner of student, I can access the data. So here I'm trying to print the name, I'm trying to print the major. Let's also print the tuition. Okay. And there was one more thing, which was age. So let's print that also. A plus age, Tweety dot age. And I want to show you, what was it, age? It was GPA, sorry. I want to show you what happens when you try to print those uninitialized variables. Like we said in the last video, the objects, like the strings, you see a null in there. And the numbers, because we haven't initialized them, you get a 0. So this is slightly different from when you have those variables that we're creating. Here we have variables that we created. Here I have a variable that I created. I wasn't able to use it until I initialized it. Here I'm actually able to call, try to print major and tuition and GPA, even though they were not initialized. Why is that? Because when you create a class, what Java does underneath the hood, when you create those instance fields, it initializes them for you. So Java will actually initialize them, but it will initialize them just to 0 and null. And if it was a Boolean, it will initialize it to false. So it'll actually initialize them for you, but it will just put like default values. In the last video, we talked about the noArgs constructor that we can write, which is a constructor that takes no arguments. So here what I did was, when I started writing my constructors, I didn't want to break the code in main that was using the constructors, the default constructor. So what I did was I created the noArgs constructor. Here I have it doing nothing. If I wanted to, I could have it do something. So I can, for example, say, name equal to no name, major equal to undecided. So if I wanted to put something in there, I could also do it. But this is called the noArgs constructor. Now, it really doesn't make sense to create a student with no name and undecided, because then you'll have a bunch of students that have no name, which really makes no sense. So the noArgs constructor doesn't make sense in all situations. You have to look at the class you're writing. If it makes sense, do it. If it doesn't make sense, don't put it in. Now let's go back and look at the string class. And remember, we said string is a class. However, the way we always created strings, we were saying string name equal to something. We never used the new keyword. But all the other classes that we're using, like, the student that I just write, or scanner keyboard equal new scanner, print writer PW equal new print writer, file X equal new file. We've always been using the word new. So with string, since it's a class, why weren't we using the word new? Well, the reason we haven't been using the word new is because we want to write strings really, really fast. But Java lets us actually. So I could just say string y equal to Java. Okay, or I can say string z equal to new string Java. I can actually use the keyword new if I wanted to. But because strings are so widely used in Java, they made them, they made the way to create a string on the fly easier, just as if it was a primitive data type. And that's why sometimes students confuse primitive data types with strings. But to prove to ourselves that a string is an object, we remind ourselves that we can call methods on it, because that's what you can do with objects that belong to classes. You can call methods on them. However, if I had an int like x up here, if I say x dot, I will not get methods. And that's because they are primitive data types. So strings are classes. We could have used the word new if you wanted to create them, but we don't, because it's simpler to just say what it's equal to. So we save writing new string again. The next thing I want to talk about is passing objects to methods. Now remember, when we talked about methods in the last chapter, we said when we pass information to a method, it's passed by value. The value is getting copied over. So let's just kind of remind ourselves, if I had in main, a variable, let's say x was 10, and then I called a method, let's change to 100, like we did before, and change to 100 took, let's say, an x, what happens is this x that's here gets copied over. We said gets copied over. And so my change to 100 now has a 10 in there. If change to 100 comes and change this 10 to 100, I'm changing the variable in my method. I am not touching main. Main will not see that change. So this was called pass by value. The value is copied over. Now, this is not what's going to happen when we talk about objects. let me show you what's going to happen when we talk about objects. Let's say in main, I have a student, X, okay, and X has the name, let's say their name is Tweety, and they are a CS student. Let's say I want to call a method called change student. Okay. Now let's remind ourselves that student X is stored in RAM in two ways, as two parts. I have variable X, okay, and this is pointing to the new student. So when I say student X equal new student, this new student gets created in RAM, and X, let's say it's created at location 64. This X now is storing location 64. So it's pointing to this location in RAM. So I have two things that are being stored. I have the variable X and I have the actual student object. If I call a method and this method is taking a student as input, let's call it student Y, what's going to get copied over is what is in the variable. The variable X is storing the address. So the address is actually going to get copied over. So now this student in the new method is going to say, I am pointing to location 64. So this variable is also pointing to this object. Now I have two variables that are pointing to this object, the variable in main and the variable in the method. And because this variable in the method has access to the memory location, any change made here to this variable is actually making changes over here. That means changes made by the method are going to be actually seen in main. Main is going to see the change. Let's go try that out. So here, what I'm going to do is I'm going to write a method. This method is not going to be part of the class. It's going to be a static method. So I'm going to say public static void change me. And it's going to take a student, S, and what it's going to do is going to go to the student, and it's going to say set the name to changed, and it's going to say set the tuition to 1,000, and so it's going to do two changes. Now let's go down to main and start using this. Okay. So here, let's say let's try to reduce this a little. So let's use snake. So here I have student S2. Let's just take all this out. Okay. So here I have S5 and their name is Snake and they have a tuition of 8,000, and let's just print them out just to make sure that we are seeing the right information. So I'm going to say S5's name is S5 dot get name plus tuition S5 dot get tuition. Okay. So here, this student, let's just comment out the rest of the code so we don't get extra things printed for us. So if I print S5, I should get that they are a snake and have a tuition of 8,000. Okay. Now what I'm going to do is I'm going to call the change me method on it. So I'm going to say change me. I'm going to give you S. And because this is a static method, I don't have to put something before. I don't say S dot. Okay, I don't have to. But I'm going to give it the student S5. Now I want to see what happened after this method got called. I see that S5 has changed. Their tuition has changed. Their name has changed. Why? Because when I went and I called change me on S5, S5 got the location, the memory location, the address of where this new student object lives. And so change me had access to the actual memory location in RAM of the actual student object. And so when it changed, was calling the set methods, it was actually changing this student object, and the object got changed. This is called pass by reference. I am giving you a reference to my object. I am giving you the address of my object. And this is because these variables store a reference. They store the address of the actual object. So this is called pass by reference. This is good, and it's dangerous. It's good because you can have a method actually modify your object. It is dangerous because you can have a method modifying your object. So you have to be really careful when you're calling methods that you make sure that they are not going to be modifying the object in a bad way. Now, just like methods can take objects as input, they can also return objects. So here I have a method that's creating a student. It needs to return a student. So it's going to create a student, it's going to save information, and at the end, I return the student object. So I can actually return students also. I can return objects. So let's try writing it here. Public static void create student. I need to, oops, not void. We need to make it create a student. So we're going to have it return a student to object. So here, because I want it to create a student, I'm going to start by creating a student. New student 2. Let's say it is Lizard, and they are engineering. Okay. Do I have a typo? I don't see a typo. Student. Oh, I forgot a variable. Let's say X. Okay, and I can go to X and say set the tuition to 9,000, and I can say X dot, set their GPA to 3.7, for example, floats. So I can create a student, set all the information. Oops, this should be set tuition. I can create a new student, set all the information, and I'm done. I'm done creating it. I'm going to return the student that I just created. So I'm going to return the variable that's pointing to the student. What am I actually returning? I am returning the address of the student object. Okay, I'm returning an address. So in main, I can actually come and call create student. So I'm going to come here and say create student. Okay, create student doesn't take anything as input, and it returns a student object. So I'm going to here come and say student 2, let's say new student equal. So whatever it's returning, the address that it's returning is going to get stored in new student. And now I can print the contents. So let me just take this line and kind of copy it. Okay, so I can say it's new student. Name, and their tuition is new student get tuition. And I have a typo, student. Okay, so let's see if we get that they are Lizard and they're engineering. They're Lizard, we didn't print the engineering part, but we could have. So here we're seeing that you can have methods that return objects. So you can have methods that take objects, those classes that we're writing, and we can have methods that return the objects, just like you did with primitive data types, just like you did with strings. So for the classwork today, what I want you to do is practice writing constructors. So you're going to create a student class that stores the name, banner ID, which are strings. You're going to write me 3 constructors, so different constructors that take different arguments. You're going to write your accessor and mutator methods. And what I want you to do is write a print method. And this is not a static method. It's just a method on the class that prints the name and banner ID in this format. And then I want you to write a main method that displays a menu to the user, asking them what they want to enter. Do they want to only enter the student's name, or do they want to enter the student's name and banner ID? Based on what the user chooses, you're going to ask the information, the string name or string name and banner ID, and you're going to call the appropriate constructor to create the object. And in the end, you are going to be, you're going to print the information back to the user. Now, if the user chooses the option to just enter a name and they don't want to enter a banner ID, I want you to set the banner ID to the empty string, so just empty quotes. So try doing this classwork and let me know if you have any questions.